one option, 64 times 64 to the second power. This is 64 to the third. Remember, we talked about from here I can get this, and from here I can get that. 4 squared is 16. Now I will simplify because I simplify factors. And then the final answer is 4 times 64 squared. And I can multiply that using the calculator. Now, if they want it in an exponential form, I'll show you in a minute. So this was 4 times 64 squared. And I got 16,384. Okay, now let's read the fine print, if there is one. What is wrong in this process? What is wrong in the process is that he used an exponential rule that does not exist. The exponential rule requires the bases when we divide to be the same. So this is not possible. The student attempted to use the quotient rule with unequal exponents. That's false. Who cares about the exponents? The student attempted to use the power rule with unequal power rule. The quotient rule, the power rule, no. They attempted to use the quotient rule with unequal bases. Then that is wrong. We don't have a rule for that when the bases are not the same. Good. 29. Use the power rules for exponents to simplify the expression. Yes or no?
I actually have a question. Can we go back to the
Yes.
problem?
Yes?
So when you did 64 times 64 squared, could you have just done 64 times 64 times 64?
Yes, but I still had a 64 squared at the end.
Okay.
Of course. Absolutely. Good. Do we need to find them? Yes?
Yes, please.
Good. So what will the missing exponent be? So that 13 minus what number is 3?
10?
Yeah.
Oh, that was a lot easier than it looked.
Yeah.
I'm sorry.
The same thing here. Let's work on this one. But the best option is to put it in the fraction form. So m to whatever exponent divided by m to the 12th equals m to the 16th. And this is something that we talked about and we talked about and we talked about. What is it? And a proportion. So when I multiply, m to whatever has to equal m to the 28th because I copy the base and multiply the exponents. So obviously this needs to be 28 because I copy the base. From 28 I subtract 12 to get 16. See, proportions are the key in many, many examples. Okay, this is just stretching it for no reason. Okay. Okay, these are like simplify where possible. Okay, so let's take a look at this. Z to B times Z to B. So they're trying to throw us off. It's Z to which power?
B.
2B, of course.
2B.
Yes.
2Z.
So Z raised to 2B. We copy the base, add the exponents. What about B? Z to B plus Z to B. An apple plus another apple.
Is 2.
2Z to B. So please understand the difference. We did this before. understand the difference between these two. One of them is multiplication. I have to copy the base and add the exponents because the bases are the same. But here, I'm adding. So imagine when I'm adding an apple to an apple, I cannot get 2 apples squared. So when I add an apple to an apple, I get 2 apples. What about C? Because bases are the same, the power at the top is B and the power at the bottom is A. So how do I simplify this?
Z to the B
B minus A. That's the rule. Very good. Now here I multiply 2 exponential notations with the same base. One has exponent B, the other one has exponent A.
Z to the B plus A.
Yes, so Z to B plus A. Now careful, the last one. This is like Z to the third plus Z to the second. Is there any chance I can combine or simplify E? The answer is not. I cannot, because I can never combine Z to the third power to Z to the second power. Unless they say, well, B and A are the same, then I can. But if B and A are not the same, this is like adding apples to trees.
2 prime numbers.
So we can add prime numbers, but we cannot add different entities.
Right.
Good. 38. Okay, the same thing. We know this. The same thing. Okay, yeah, let's work on this one, as we are close to finishing this section, so we can move on. Am I on page 5? Yes, I am. So we have Z to 6t minus 2 over Z to t. Because bases are the same, we copy the base. What happens with the exponents?
What was the question?
So we divide. I copy the base because bases are the same. What happens with the exponents? What do I write?
Subtract them.
6t minus 2 and minus t. Yes. So Z, and now what is the power? 6 apples minus an apple.
It's 5.
5t minus 2. That's it. Do we understand this problem?
Yes.
Okay. Moving on. 41, same thing. 42. Okay, let's look at 42. And this is Q to negative 3R and everything to the third power. And let's see the last one. Okay, the same thing. Good. So, I copy the base, and what do I do with the exponents?
Multiply.
Yes, negative 3R times 3 is negative 9R. I have to rewrite it as 1 over Q to 9R, and that's it. Why? Because number one, we don't like negative exponents in the final answer, and number two, I have to use all exponential rules till no exponential rule can be applied. Okay.
Wait,
Yes.
so R wouldn't get cubed either?
Say it again.
So the R
No,
wouldn't
no,
be-
no, no. We multiply the exponents. There is only one factor. So I copy the base and I multiply the exponent. This is not a distributive law. This is negative 3 times R times 3, which is negative 9R. We're not distributing. The distributive law would have been something like this. Then I would have distributed. But this is a factor, factor, factor. So I simply apply the I apply the associative and the commutative laws. So I rearrange. -3 times 3 is -9 times r. This would have been the distributive law that must involve addition or subtraction and multiplication, but that's not the case here. We're not adding terms, we're not distributing. These are just 3 factors. Is that okay?
Yes.
Perfect. So that was the end of the practice 5.4 A. So now let's take a look at 5.4 B. Good. This is more human friendly. Meaning it's a little bit, it's about half of the other number. Okay. A student incorrectly divided this by 3 to obtain this. Okay, we haven't talked about this. So let's talk about it now. So this is 5.4 part B in practice. Okay, so we have 3x squared minus 15x divided by 3. At the top we have 2 terms, 3x squared and -15x. In the denominator we have 1 term. Only when we divide whatever number of terms by 1 term, we are allowed to, option 1, to separate the fractions. Only because it's 1 term. Don't correct anything because I'm going to erase it. But if I have this situation, if I have 2 terms in the denominator, I will never be able to write this. It will not make any sense. Meaning I will not be able to continue, even if I write it. So when the denominator has 1 term, I am allowed to separate the fraction. If there are 2 terms in the numerator, I have 2 fractions. If I have 3 terms in the numerator, I have 3 fractions, and so on and so forth. Now, I am allowed to simplify each fraction individually. 3 divided by 3 is 1, so I get x squared. 3 divided by 3 is 1. 15 divided by 3 is 5. So I finished the simplification. So this is option 1. Option 2 is slightly more sophisticated, and we will get to this. Here's option 2. A long time ago, I said, do not ever, ever, ever try to simplify factors with terms. This will be a terrible mistake. Terrible, terrible, terrible. If you do this and people ask you who taught you algebra, do not mention my name. Because they will come after me. And rightfully so. So this is not allowed. Never, ever, 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 ever. Because this is part of a term. And this is a factor. How come it's a factor? Because it's multiplied by 1. There's nothing else with plus or minus to the side. So this is never, please. Never. But then what is option 2? Here is option 2. 3x squared minus 15x divided by 3. Notice that these 2 terms have a common factor. What is the common factor? Well, it's 3x. How come? Careful, because this is very important for what follows next. 3x times what is 3x squared? Can anyone give us an answer here? It's okay if you're wrong.
X.
Indeed. 3x times x, copy the base, add the exponents, I get 3x squared. Obviously minus. 3x times what is negative 15x? I already took care of the sign. So what should this be?
Five.
Indeed. Let's check again. 3x times x is 3x squared. 3x times negative 5 is negative 15x. Now I am allowed to simplify factors because this is a factor, this is a factor, and this is a factor. I don't have terms in the numerator anymore. This is a term, this is a term, but now I no longer have terms. I have one factor, I have the second factor, and I have the third factor. And now I'm not simplifying a term or a piece of a term with a factor. I'm simplifying a factor with a factor. So the simplified form is x outside and in quantity x minus 5. Yes, if you want to distribute it, you can. But you will have to get the same thing, mandatory, which is x squared minus 5x. Option 2 is more sophisticated. And option 2 will come up soon. Again, this is allowed, option 1 is allowed only because the denominator is one term. Is it allowed with more than? Yes, but I will not be able to simplify, so I will never do that. But if there is only one term, I can separate the fraction into one fraction plus 2. If I have 3 terms, I will have 1, 2, 3 fractions. If I have 4 terms at the top, 4 fractions, and so on and so forth. And then I simplify individually, each fraction individually. Option 2 is slightly more sophisticated because I have to realize that there is a common factor. These 2 terms have a common factor of 3x. When I pull the factor out, I say to myself, wait a minute, is this correct? And the answer is yes, because 3x times x is this, and 3x times negative 5 is this. And now I'm allowed to simplify factors, because now the top does not have terms anymore. It has 3 factors, because I factored.
We do another problem using option 2.
I'm sorry?
Could we do another problem using option 2?
Oh, we're going to have half of the semester on option 2. You're going to, yes.
I've used option 1 so far.
Oh, trust me, option 2 is a major part of this class.
Oh,
Say it again.
I said, oh yeah.
Oh yes, it is a lot. Here's another one. So 15m squared minus 12m over 3m. So choose the option.
Option 2, please.
Okay, so we have to find the common factor, the greatest common factor to be exact. Greatest.
3m.
Again, 3m indeed. And now we have to see what is left in parentheses. We have to be very careful. I started with 2 terms. I have to have 2 terms. And then I check. Yes. You said 5m minus?
Is that 4?
Perfect. Let's check. 3m times 5m is 15m squared. 3m times negative 4 is negative 12. At this point, I am allowed to simplify because I'm simplifying factors. And the final form is 5m minus 4. Good. So here's another. Now I think we had the idea, so let's work on this individually for a minute. You have to factor the greatest common factor from all 3. You cannot pick and choose because then you still have terms in there. So you have to pick, you have to find the greatest common factor of all 3 terms, if there is one. Again, I cannot stress enough. I'll still wait for you to. Do not simplify 15 with 60x with x. That will be an absolute terrible, terrible situation. You can only simplify factors, never simplify